the world computer. So what we're covering in this presentation, we're going to look at what DFINITY really is. We're going to look at WebAssembly, which is a new standard for developing applications, and how that feeds into a new paradigm for developing applications, or a new application architecture called, or that we're calling Cloud 3. You can insert your buzzword or buzz phrase there. Then we can go, and this is the super tech stuff, into the DFINITY network, into threshold relay, which is the way that we create randomness. This has never been achieved before, and we've actually solved it, which is fantastic. This is our secret sauce. And very briefly, probabilistic slot consensus. The beauty of DFINITY is that because we can agree on a really, really reliable source of randomness, which no one else can do, we don't really need a strong consensus tooling. We can just kind of just say, hey, we've got randomness, we'll just give it to someone randomly. And it's really about just selecting the set of people who we give the ability to decide what is the canonical course of events. So we need very simple, simple consensus. And some core points, just to begin, and we'll review these at the end. We are entering a new age of software architecture. The cloud will be at the heart of application design. DFINITY can offer, by virtue of the fact it's a blockchain computer, a more secure, 100% uptime, and an often less expensive alternative to large centralized cloud providers like Amazon and Google Azure, Microsoft Azure. At the heart of DFINITY, again, WebAssembly, blockchain, and threshold relay. I have to hammer home the importance of randomness and the importance of threshold relay and creating that. So for those of you who, who's been interested in blockchain for more than a couple of years? Do we have a couple of people? Yeah, right. So we've been waiting a long time for something amazing to come along. There's been lots and lots of promises, and yet we just haven't, it hasn't happened. I mean, I got into this like wholesale in 2014, made it my life. And the promise was that we would see something new, something that would change the world, not just another version of Bitcoin, and that hasn't happened. And the reason it hasn't happened is that we haven't had randomness. Andreas. Okay. So what is DFINITY? The idea of DFINITY is that it's a world computer. It's a computer that everyone has democratic access to. It's fully egalitarian, and it doesn't exclude participation or centralized control over who can participate in it or use it. It scales with the number of computers that are attached to the network. And as Wolfgang pointed out, that is the secret. If you want to be competitive, if you want to create a truly powerful and effective platform for people to use, you need to make sure that it scales with the number of people who are using it or the number of computers that are connected to it. Otherwise, as in the case of Bitcoin and currently Ethereum, you have this one tool, this one platform that has one speed. It can only go so fast, and it can only process so many transactions. It can only do so much computation. So imagine if computers just did not get faster. If we were all just stuck still using computers from the 80s. I mean, that is where blockchain is right now. And we have to somehow break free of this. And again, we do that using randomness. It's highly performant, it's secure, it's self-governing. Is everyone familiar with with Bitcoin Cash? The real Bitcoin. So recently, the core developers of Bitcoin, the direct descendants, what you might say, of Bitcoin itself, of Satoshi Nakamoto, they came up with an update to fix Bitcoin and make it more performant. But there was a lot of disagreement about whether or not this update was in the true spirit of Bitcoin. And so what wound up happening is some people chose to adopt the update, some people chose not to, and the network split in two directions. And that's all well and good, except that now we've got two Bitcoins. So which is the real one? And that's a really confusing thing if you're trying to run a corner store. That's not a property of currency. It's not like there's suddenly, €2 and you've got some people accept one and some people accept the other and most people kind of accepted both begrudgingly, I mean, that is confusing. And so what we need to find is a way to make sure that we can all agree that, yes, even if we don't agree that this is the right update, at least most people do, and find, the dissenting few can go along with a clear majority, and that the rules about deciding which direction to go on are clearly defined and everyone buys into those rules, if not into each specific decision. And that's governance, right? I mean, that's why we have governments. It's so that we don't split into multiple different nations every time we have a disagreement. So DFINITY, again, focusing on that randomness, we produce perfectly unpredictable randomness, technically pseudo-randomness. If there's any mathematicians or cryptographers in the audience who are going to put up their hand and say, well, actually, and then we can have this whole huge conversation about the nature of randomness. And it conforms to next generation application design standards, and that's WebAssembly. So WebAssembly and Cloud 3. So we can divide somewhat arbitrarily. We don't, again, people, this is kind of a bit of a story that people spin about the generations of the internet and the generations of computing with networked computers. Initially, we have the protocol age. The protocol age was the 80s and 90s. It was back in the day when anyone who built something that ran on the internet or that used the internet used the transmission control protocol and the internet protocol. Then, during the dot-com boom, people realized that, wow, the internet is an incredibly powerful place to do business. And they started building services, business services, on top of or using the transmission control protocol and the internet protocol. And what that created was this competitive advantage if you would use these tools that were developed by for-profit businesses. The problem with that, of course, is that those for-profit businesses control who gets to use their tools. And that characterizes the oligopolistic nature of the current web. So we want to change that. And if we want to change that, the only way to do that is to go back to a world or an internet that is ruled by protocols, not by corporations. And that is the dream of blockchain in general. Certainly it's the dream of more recent blockchain platforms like Ethereum. But in order to do that, this isn't just something we can just spin up. This isn't just a matter of getting a bunch of smart people in a room. This takes some really, really powerful innovation. And I characterize this next stage as protocols that behave like platforms, the decentralized internet, the re-decentralized internet. Protocols that give you the same services that we're used to receiving from real large businesses, corporations like Google and Amazon. So that being the case, if we are going to create a solution to this problem, if we're going to create a competitive protocol that can actually compete with these existing gigantic businesses, let's bear in mind, you don't just randomly come up with some science project that can compete with Google or Amazon. That's a huge problem. It's a huge challenge. Think of the size of PayPal. It's immense, and that's what originally Bitcoin set out to compete with. But as we all know, Bitcoin is now digital gold, where it used to be digital cash. It has not succeeded in its stated goal because that was actually far more challenging than a lot of people, than at least the core developers originally anticipated. So we need to come up with a value proposition that's differentiated. And the best way to do that is to look at what are the problems with information technology today. We have vendor lock-in. So if you want to build a major service, say like Dropbox, for example, you need to look for a pre-existing business that can provide you the infrastructure you need to get off the ground. But then you've got to somehow leave that business once you've outgrown it, or if you decide that you don't want to be beholden to someone else's business decisions for the running of your particular business. And interestingly, Dropbox themselves migrated away at phenomenal expense from Amazon Web Services, from running their service on Amazon, and have experienced tremendous profits as a result. But the cost of migration was phenomenal. Essentially, they had to run 2 versions of Dropbox simultaneously and decide where your data would be stored. Is it on the Amazon Web Services portion of Dropbox, or is it on the self-hosted cell phone servers that belong to Dropbox? Then you have inter-version and inter-platform compatibility problems. So recently, I have OmniGraffle. It's a kind of a graph. It's like a diagramming. It's a diagramming kind of piece of software. It's really great. It's really powerful. I'm not that great at using it, but I like it. And I went to update it, and I updated it. And what do you know? If it doesn't ask me for a new key, I had to pay for a new license. So I'd already bought the software, used it for a year, and now they want another $100 to just use OmniGraffle 7 versus OmniGraffle 6, which as far as I can tell is pretty much the same piece of software. And these kind of compatibility problems are just a classic symptom of the central control and the centralized control of updating software. Yet even saying that, in updating software, we all have to update our own software. Suddenly, someone makes an update, and then it's beholden on us to go and click update, and then wait and restart your computer, and then it's like, oh man, I'm missing an hour. You miss a meeting, or what have you. I mean, if you've updated Apple, it's the latest Mac OS, it takes forever. There are compatibility issues between different platforms as well. Again, Mac OS, Windows. It's labor intensive to update, it's labor intensive to maintain infrastructure. So let's look at what Dropbox did, right? They migrated away from Amazon Web Services, but then first of all, they had to do that migration. Then they had to support a huge team to maintain all of the hardware that they'd bought, troubleshoot it, update different processes that are running on that hardware, and also pay the rent for the huge data centers and deal with all that nonsense, HR, things like that. Those all roll into, these are not things we normally anticipate as being part of running an online business, but with today's way of running IT, that is part of it. And then sometimes it all just goes down. I mean, again, I'm being mean to Amazon, right? But Amazon's amazing, but S3 went down last year. What the hell, man? For days. It was huge. It just crashed the internet. And this happens regularly. It's a major problem, especially if you're critically reliant on the internet for your business. And that's if you don't get hacked. Yahoo got hacked, and they lost 3 billion customer records. Like, are you kidding me? That's everything. That's like that's everyone who's ever been online ever has had all of their data stolen from Yahoo. And I mean, that is just indicative of the problems that come with central hosting. And it's something that is an easy way to differentiate a decentralized platform from, because decentralized protocols or platforms, they never shut down. They're always online, and they never get hacked. So what should the IT experience be? Zero downtime. It should run itself. No humans, no mistakes. Again, just to focus on downtime and hacks, 90% of that stuff, human error. Those are the same people who you have to hire your HR to deal with. Your IT should not be a point of business vulnerability. There should only be one version of any particular piece of software, obviously, because when you buy a hammer, you've got it for life. So why do we have to continually keep rebuying software? And we want to make sure that we have full data security and data privacy. Incidentally, on that point, there are new legislations that we're all aware about. I mean, certainly here, but I'm not fully sure what the story is with you guys' data protection laws, but I know you have the right to be forgotten. That's very problematic. I mean, how do you find where you've stored customer data if you've given it to a third party to store? Even on your own servers. I mean, how do you track down? How do you keep track of all of that data in order to just be compliant? In New Zealand and Australia, we have our own data protection laws that are coming into effect, and they're phenomenally stringent, to the point where people are no longer really going to be able to manage their own data because it's going to take their own business data, because it's going to take so much compliance. So we need a solution to all that stuff, and there are a lot of there are lots of ideas around doing that. Looking specifically at the application layer, or at application design, this idea of Cloud 3, which we generally talk about as being at DFINITY as being the decentralized cloud, but it's certainly, I'm sure there's an incumbent version of Cloud 3 that sees this as centralized, and it fits this model. You have an application, but you don't store that application on your phone, right? I mean, look at this thing, it's tiny. It's good for looking, it's got a screen on it, but you don't want to do any hardcore computation here, and you certainly don't want to be storing data here. Look at your form factor restrictions are ridiculous. Compare that to a data center that has zero form factor restriction, whatever. You can do anything on that thing, and you can have super cheap cooling. You don't have to worry about battery life. So just form factors themselves, we know that this is going to push computation out of this device. It'll just get squeezed out of it as consumers demand smaller devices, longer battery life. Inevitably, that is going to be these rich, featureful applications are going to be pushed into the data center, especially because the sheer bandwidth, I mean, like 4G gives you like 5 megabytes a second. It's crazy, for someone who grew up on 56K. It's like science fiction stuff. And you can download a user interface just like that, just from the cloud. There's no reason why we store these rich applications on our devices these days when we're almost always connected. And so there's a clear push in the direction of storing applications in the cloud. And we can see this writ large in the collaboration between Apple, Google, Microsoft, and Mozilla Firefox in the creation of a new in-browser execution environment called WebAssembly. And the beauty of WebAssembly is it lets you run any code you like in your browser. So, I mean, we're all familiar with JavaScript, which gives us these nice rich web pages, and you type in half of the search term, and then it drops down, and it gives you the whole thing, and you click on it, and everything's happy because you didn't know how to spell that anyway. You only knew the first few letters. Those are some of the awesome things that JavaScript gives us. But wouldn't it be nice if we could run Photoshop in the browser and didn't have to keep the whole thing on your actual computer? Or say Premiere, Adobe Premiere. Especially if you've ever tried to render a movie file, it takes bloody forever. Because we're form factor restricted. If we could have all of this stuff stored and processed remotely in a data center, it would completely change our experience of computing. And WebAssembly gives us the ability to do this purely by being able to turn any code at all into something that can be run in a browser and then ultimately translated into something that can be run on your CPU. And by virtue of the fact that's any code at all, that means that the old software that you had that only worked on Microsoft, now that can work in your Chrome browser on your Apple laptop, or in Safari, or in Internet Explorer, if that's what you're into. And I mean, the depth of significance of WebAssembly is impossible to overstate. I mean, this will completely change the way that we design applications. And it only came out, this is 2018, right? So last year. Interestingly, if you think about this, now that Apple, Google, and Microsoft have this new way of writing software that runs on everyone's platforms and in browser, and they already have these huge data centers that they're hosting, the next step is naturally to start building the hardware that goes into those data centers. And you can be sure that, that Intel is not going to be too happy about this. This randomly just popped up. I was at breakfast the other day, and this very conveniently popped up in my news feed. Apple working on their own CPUs. I mean, they already did that with the phone, but I mean how many actual chip designers are actually building chips for phones? You've got Qualcomm and Samsung. And those are diversified businesses, but you don't, actually Qualcomm's not, but that diversified. But certainly Intel, their bread and butter is CPUs. They can't afford to have Apple going and stealing this huge contract for them. I mean, that's all consumer computers. Interestingly, back in 2006, I don't know if anyone remembers, HP tried to spin out their assembly business, their consumer computer business. And the shareholders just did not understand. It looked like it was a winner. They knew deep down that ultimately computing is going to be vertically integrated. It's inevitable in the current paradigm. The same company that sells you a computer is going to create the software for it and also make the hardware that's inside it. That's inevitable. But of course, that's not good for us. It's what Cory Doctorow calls the war on general computation, because people don't want you to be able to do what you want to do with your hardware. That's not advantageous to business. People want to turn hardware and people want to turn software into a product, a single unified whole that they control and that you consume. They don't want. No one likes. That's why it's so hard to open an Apple computer. They've got those weird. They're always changing the screws and stuff because they don't want you upgrading the RAM. That's just not on the cards for them. That's for them to do. So the decentralized cloud. Well, the decentralized cloud is essentially the same as the centralized cloud, and it even uses WebAssembly. The only difference is it stores the code for your actual applications in a decentralized network of computers, and it does that using WebAssembly, the WebAssembly virtual machine, and commodity hardware that like Intel chips. So to recap very quickly about this whole Cloud 3 subject, the incumbent model is oligopolistic, and the DFINITY model, or the world computer model, which, because I don't necessarily insist that you believe that DFINITY is going to succeed, what I'm trying to paint is a picture of inevitability. And the world computer model is decentralized. It's monolithic versus the incumbent complex solution that involves multiple moving parts, multiple services. The incumbents have human security that we know fails relentlessly time and time again. Whereas DFINITY and the world computing model uses blockchain and strong cryptography to enable absolute, flawless, perfect security. The incumbents, sometimes their service isn't there when you go looking for it. Whereas with blockchains, it's always up. I mean, when was the last time Bitcoin went down? I think it was 2012, 11 even. And you need DevOps and people to maintain your incumbent solution, whereas DFINITY is completely self-maintaining. It doesn't require. All you do is upload and forget. If you're serving software to your customers. Incidentally, it also uses commodity hardware, which is this convenient little thing that I get to tack on the bottom, which is Intel or what have you, any RAM manufacturer, any hard drive manufacturer, any chip manufacturer, AMD, NVIDIA, the rest of them. Whereas the incumbents, and this should say vertically integrated, which is really the enemy of the consumer, vertically integrated businesses, because there's absolutely, that's total control over a product set. So now we go into the really tricky stuff, and unfortunately my slides have been completely butchered and not reassembled by on the road kind of development and a recent meeting. But it's worth pointing out, just as Wolfgang was mentioning, DFINITY uses randomness to kind of completely circumvent that triangle. Usually you do have to trade off centralization versus security and the cost of using a network. Whereas for us, Because we have randomness, we can randomly select participants to perform certain roles in a network, and those participants have no way of knowing who they're going to be, so they have no way of anticipating their advantageous position in the network itself. So the key trick is we select, instead of one computer to lead the network every time, which is what Bitcoin does, we select a whole committee of computers that simultaneously collaborate on coming to an agreement. And because we have this randomness, we can plug a whole bunch of additional networks into the core DFINITY network and give them the ability to do exactly the same thing, and then store a digital signature of their network at any moment in time of their state, of say the state of their hard drive, into the central DFINITY blockchain. And that means we can plug in as many of these networks as we like, and as many computers as we like, super easily, without this enormously growing blockchain, or without the threat of centralization. Now, this is the part where I normally describe threshold signatures, and these are my incomplete slides. Who's familiar with public key cryptography or asymmetric cryptography? So we've got a few people. Okay, so this is probably worth at least having a stab at. So with public key cryptography, it's kind of like you have one key that locks a door. And that's great. You can distribute that, you can give that to anyone, provided all it does is lock the door. You have another key that unlocks the door. If you just hang on to that key that unlocks the door, you can give the key that locks the door to as many people as you like. No one's getting in there. The worst situation is you're going to turn up and there's going to be a locked door, which you can unlock quite happily. The other thing you can do, and this is where that metaphor immediately completely breaks down, is you can use a public key to verify a signature that has been placed on a piece of data. But that signature can only be created by the private key. So it's kind of like the key that locks the door is also the key that can sign a piece of data. And the key that unlocks the door is also the key that can verify a piece of data, or can verify a signature on a piece of data. Does that make sense, just generally, to people? I see some bemused faces, but mostly nodding with tremendous enthusiasm, which is great. So threshold cryptography, and this is a particularly flawed slide here, is exactly the same, only instead of having one key, you have a whole bunch of pieces of a key, and you just need a majority to perform any particular function. But the really cool thing about it is that instead of a bunch of participants having to sign a piece of data in order to create a complete signature, instead what you have is a bunch of participants can create a piece of a signature, and as soon as you have a majority, you can assemble a complete signature that can then be validated or verified by the public key that, of course, everyone has shared and everyone has access to. So the key takeaway is that with threshold cryptography, a number of computers can create pieces of a signature, any combination of which, provided it's a majority, can create a complete signature that indicates that, yes, all of these participants found this piece of data and agreed to sign it and then distribute their piece of a signature. It's kind of like jury duty, right? Or voting on a board. It means that if this, provided you have a majority of these participants, a complete signature that can be created that says, yes, anyone who signed this liked what was in it or agreed whatever was implied by signing it. And what that signature is in a digital form is essentially a random jumble of numbers that no one ever could have predicted. And the beauty of that is we can use that to select the committee that is going to participate in the next round of randomness creation, or the next round of what we call threshold relay. So to run through the example here, we use any kind of randomness we like, just anything. You can just pick numbers out of a hat, it doesn't matter, and we use that to select out of everyone who's participating in the DFINITY network, just to shoot back a few slides, this is this notarization committee. So we have the miners, we have the validators, that's everyone who's plugged into the network simultaneously, and we want to select a small group of them to perform a certain function. And we don't know how many miners we're going to have. So we want to make sure that we don't wind up blowing this out and having millions and millions of computers continuously repeating all of this work, which is what they do in Bitcoin. We want to make sure this is a very small group and they're doing something very easy. So we use this randomness to select the small group from the entire miner base or the validator base. And then that small group, using threshold cryptography, signs the randomness or creates a signature for the randomness that was used to select it. And remember, that is a total jumble of numbers. It's totally unpredictable. There's no way of anyone knowing what is going to come out. And then we use that to select the next group of notaries, this next special group, and they sign the piece of randomness that was used to select them, and then that piece of randomness, if you follow the diagram, right, is used to select the next group of notaries. And this is what we call threshold relay, and this is the secret to making blockchain actually work. So the challenge with blockchain forever has been finding a way to select a network leader or public blockchain that will be the one who decides what is the next thing that gets added to the chain. It's really hard to do. I mean, you've got to make it so no one can cheat this. You've got to make it so no one knows what's going to happen next. And that's what Bitcoin mining is all about. They spend like as much energy as Ireland to make this happen, but we can just do it like this. It's amazing. And the beauty is, it's always a couple of hundred people. It's always 400 people or 400 nodes that are involved in that process, rather than randomly selecting one. And that's completely critical. I'm mischaracterizing this slightly, but it's basically a magic bullet for all problems of blockchain. So, Wolfgang, to your triangle, if you can just speed up everything 1 million times, then who cares if you have to make a trade-off, right? I mean, that's the secret of DFINITY. Instead of having to make these, do we want to centralize it a bit and get a bit more speed, or are we going to kind of slow this down to be more decentralized? We don't have to worry about that. We can just blast right past all of that, not make any of those compromises, and just have a phenomenally performant network because we have randomness. And interestingly, now that we have this group, we can use them to we can use them to sign blocks. And so this is effectively the process. The same committee that we've selected to continually create randomness, we use them to sign the block headers, which is what the block creator would be doing in Bitcoin. And probabilistic slot consensus. So I know what you're all thinking, and I can see these skeptical looks. What if 2 blocks get signed simultaneously by the notary? Well, what we do is we use the randomness created by the notary to order all of the participants in the network completely randomly. And so if there are 2 blocks, they each have the creator of a block has a rank attached to it, and we just use that to pick one or the other. And let's see, I don't want Dom to to start talking suddenly really loudly. So I'll just turn this off or not.
We are. This is the DFINITY test network.
Well, this is, if we had good internet, this would be it running. Let's see. We'll try it one more time. It's really amazing. This is like possibly the most amazing thing I think I've ever seen in blockchain. This demo from October 2017.
We are. This is the DFINITY test network.
Maybe not.
I'll cycle through the panels quickly to give you a quick overview. Network shows the nodes in the network that are collaborating to create the virtual computer. There are 500 of them. They're distributed around the world in places like Singapore and London. Currently, we're using Amazon Spot instances to keep the costs down.
Amazon there.
The recent blocks are...
So what you can see is essentially, because it's a bit hard to hear him talk, you can see these green dots are the dots participating in the threshold relay committee, and the big green dot is the dot participating in is the dot that actually creates the block each time around. So just in review, we are entering a new age of software architecture. The cloud will be at the heart of application design. DFINITY offers a more secure and often less expensive alternative to large centralized cloud providers for all the points described, but largely because it's 100% up. It never goes down. It never leaks your data. It doesn't require a whole bunch of people to maintain it, and yeah, it's just totally awesome. And at the heart of this DFINITY is WebAssembly, blockchain, and threshold relay. Have I said that enough times? Threshold relay and randomness generation, right? That's the key. So please get involved. You can join the UK community group. There's a not quite so recently updated Telegram group there, or go to definity.org and find your respective community. And we have a bunch of information on there that's worth having a read through. Any questions?